Next up is the group working on improving desalination and drinking water sustainability in Cape May, New Jersey.
Hello everyone, I'm Chitra. Today I'm going to present to you our project on improving the sustainability of drinking water desalination in Cape May, New Jersey. In this presentation, I will walk you through the problem statement, context, strategic solutions, and the next steps. Cape May City depends on a single aging desalination plant for its drinking water, and it's nearing its end of life. Meanwhile, over-withdrawal and overconsumption of water, especially during the summer, stresses the desalination plant even more. The current water policy hasn't been effective, and people still use water unmindfully. So the city now is planning for the new desalination plant and needs a clear transition plan to extend the current lifespan of the desalination plant until the new one is ready. So where is Cape May? Cape May is located in the southernmost part of New Jersey. The city was established in 1614, and it's renowned as America's oldest seaside resort, home for pristine beaches, natural conservation sites, and national historical landmarks with very rich history and very beautiful Victorian architecture. And the city is surrounded by water, as you can see on the picture, but it's not potable. That's why the water is not only Cape May's biggest asset, but also its biggest liability. Why I said water is Cape May's biggest asset? Because it's a source of natural habitat and source of economic activity, because this is actually a city with tourism industry. And the water also becomes its liability due to some problems caused by population variability and saltwater intrusion that lead into environmental change. The city's public water system was established in 1910, over 100 years ago, and in 1950, the city used water from a shallow aquifer. After more than 40 years, there was saltwater intrusion in the shallow aquifer. So the city began drawing water from a deeper aquifer. However, it's not fresh. It's brackish water, which is a mix of fresh water and salt water. So in 1998, the city built a desalination plant to treat the brackish water and has been using ever since. Cape May has about 3,000 permanent residents, but the population can be multiplied up to 25 times in the summer because thousands of seasonal visitors. And the water consumption itself can be 7 times higher as well in the summer. So to meet summer demand, the city pumps from both shallow and deep aquifers, but the desalination system is not designed for it. And it leads to the environmental costs. The aging desalination plant struggles to meet peak water demand, and therefore we need to find strategic solutions to overcome this issue. So we come up with 4 solutions. The first one is to improve operational efficiency. Energy use is the most expensive part of the desalination process, and that's why improving operational efficiency is key to making desalination more cost-effective. Second one is to maximize desalination yield. Only 75% of brackish water can be successfully desalinated, and the rest of 25% become waste. We are looking at how we can use this 25% waste. The third one is build a water demand reduction plan, where we recommend some effective policies to reduce water use and to encourage water conservation habits. Last but not least, we also estimate the net financial impact of our major solutions. So after this section, I'm about to go further into each of these solutions. The first one is operations efficiency. So this is how the desalination process works. We use so much electricity to pump water from deep underground, about 800 feet, and use high pressure to push it through special filters or membrane. These filters remove salts and minerals, and what comes out on the other side is 75% clean, drinkable water, or as you can see, it's permeate, and 25% is waste or byproduct called concentrate. As the desalination process is so energy intensive, electricity to drive pumps is the largest expense for running the desalination plant. We recommend Cape May to install energy recovery device to save electricity and lower operating costs. What I meant by energy recovery device is written on the slide in the middle part, pressure recovery system. So how energy recovery system or device work? Some of the leftover water, called brine, still holds a lot of pressure. Instead of wasting that pressure, an energy recovery device captures it and uses it to help pressurize or to help push the next batch of brackish water. This reduces the pump's workload, saving energy, lowering costs, and making the whole process more efficient. And we also managed to convince Cape May engineers to install energy recovery devices at their new desalination plant. And they are going to install 3 devices called turbochargers, which they can recover about 70 to 85% of brine energy. To improve the desalination plant's operational efficiency, we also recommend Cape May to install solar panels besides the energy recovery devices. On the left side of the slide, as you can see, we did a payback analysis for installing energy recovery devices, which lasts up to 30 years and can reduce energy consumption by 10 to 20%. Our analysis also shows 3 to 4 years payback and could result in over $140K to $180K in lifetime cost savings. Moving on to the solar panel on the right side of the slide, we think solar panel could also be a good long-term solution to keep the electricity costs down, because the energy generation from solar can directly offset a portion of Cape May's utility bills. And here, we designed an on-site solar system using Heliscope tool. We concluded that the site can house a 133 kilowatt solar system that can generate savings of roughly $40,000 per year across 30-year asset life for 5 to 6 payback period. Next solution is maximizing desalination yield. Cape May produces about 109 million gallons of concentrate, which is still currently treated as waste. And based on our research, there are 3 potential uses of concentrate. First one is salt, minerals, and irrigation. Based on our analysis, the percentage of salt and minerals in concentrate is too low to yield any commercial value. Therefore, the best use for concentrate is irrigation, because the concentrate has low salinity and it can be used directly without any additional processing. And we also, still about maximizing desalination yield, we also calculate that if Cape May use concentrate to irrigate the city-owned properties, they can save about 1 million gallons per year. And if Cape May requires top consumers like hotels, they can also save another 5 million gallons per year. Moving on to demand reduction plan, we come up with 3 initiatives. First one is incentivizing residents through tiered pricing program. Second is incentivizing residents through rebates program. If they or residents install water efficient technology or fixtures, they can get financial incentives from the Cape May City. And last but not least is increasing community outreach. We also created a rebate model for hotels to install water-efficient shower heads and toilets. And this is a calculation of one of the larger hotels in Cape May with 65 rooms. Based on our calculations, we can save nearly 23 million gallons for a low upfront cost and while supporting the local tourism industry. And this is only for one hotel. Can you imagine if the rebate program is massively implemented in Cape May, how much water can we save? And for the next steps, here we're mapping our solutions from the easiest to the most complex ones to help Cape May City strategically allocate resources for effective planning. This is our STAR team, supervised by our amazing instructor, Professor Lynnette. And that's all from us. Thank you very much for your kind attention. We're ready for our Q&A.
Hi, thank you for the presentations. Uh, how do you think irrigation with concentrates possible for like larger plantation or at least for plantation? Is it possible?
Yeah, it is because the sand in Cape May is sandy, so the salt will filter quicker than clay soil, and the concentration of salt in the concentrate only 1.5%. So it's really viable opportunity for irrigating with concentrate. And we also recommend Cape May to have landscaping with salt tolerance indigenous plants, such as like a lot of examples like tomatoes, kale, carrots, etc. So it's actually viable opportunities. Thank you.
Sure, I'll go first. Sorry. Hello.
Oh, all right, thank you.
I know, so many hands. So, I think one question as well, just which maybe was implied by the presentation, but when you're looking at the actual water consumption or potential reduction for demand, also just kind of noting against like the brackish intrusion of the aquifers and how much capacity is actually there with intrusion, does your reduction of water usage then get to a place where you can stop the intrusion or slow it by a certain amount, just thinking about like the timeline that that aquifer has left to be a viable resource?
Right. So actually, currently we don't have any solutions for stopping the saltwater intrusion. So that's why we try to give solutions and better planning for the new desalination plants. So we can, first of all, like encourage water reduction demand by any strategic policies that I already mentioned before, and by installing solar panels and using concentrate and actually basically strategic solutions that I already mentioned. Thank you.
Hi, I was wondering if, like, you guys considered the water with like mineral and salt concentrate having, like, being utilized for landscape having a negative impact on the ecosystems.
Sorry, can you please repeat?
Like, if the water with salt and mineral concentration is going to have a negative impact on the local ecosystem.
You mean the concentrate when
Like-
it is used?
Like your initial plan, like the easiest one to
Oh,
implement. if, like-
irrigation for concentrate.
Yes.
Yeah, actually, I already said from the first person who asked that it will not harm the environment because the sand in Cape May is sandy. So the salt from the concentrate will filter quickly, and it's only 1.5 salt concentration in the concentrate. So it will not harming the soil. Thank you.